Have you ever wondered how a bolt of lightning, one of nature's most astonishing phenomena, comes to life? This breathtaking spectacle of nature, a bolt of lightning, is a result of an intricate dance of atmospheric conditions and the laws of physics. It all begins with the simple imbalance of electrical charges in the atmosphere. In a typical scenario, a cloud becomes a stage for a dramatic play of electric charges. Rising and falling air currents within the cloud stir up a frenzy, causing light, positively charged ice crystals to ascend and heavy, negatively charged ice and water droplets to descend. This creates an accumulation of charges, positive at the top and negative at the bottom. This polarization within the cloud sets the stage for what's to come next, the birth of a lightning bolt. But how does this charged cloud actually give birth to a lightning bolt? That's where things get truly fascinating. So, let's delve into the fascinating world of electric charges and atmospheric physics to understand how a lightning bolt is born. The first step of lightning formation begins with a seemingly simple process called charge separation. Now let's take a closer look at this fascinating phenomenon. Picture a cloud, a colossal collection of water droplets and ice crystals suspended in the sky. Within this cloud, there's a constant flurry of activity as air currents rise and fall, carrying particles along with them. These air currents are the architects of charge separation. As they move, they carry lighter, positively charged ice crystals upwards, while the heavier, negatively charged ice and water droplets are pulled downwards by gravity. It's like a grand atmospheric dance, with each particle playing its part. Over time, this movement of particles creates a distinct charge distribution within the cloud. The top becomes a hub of positive charges, while the bottom brims with negative charges. It's a bit like separating the whites from the yolks in an egg. Both parts are essential, but they occupy different spaces. It's important to remember that this isn't a one-off event. The process of charge separation is happening continuously within the cloud, driven by the ceaseless ebb and flow of air currents. The result is an ever-growing imbalance of electrical charges within the cloud. This separation of charges sets the stage for the next step, the formation of electric fields. But that's a story for another scene. For now, let's marvel at the fact that such a simple process, driven by air and gravity, can lead to one of nature's most spectacular displays: lightning. With the charges separated, the next step is the formation of electric fields. Now let's delve into how this unfolds. Imagine a cloud as a colossal battery. Positive charges amass at the top, while negative charges huddle at the bottom. This separation of charges, much like the poles of a battery, creates a colossal electric field within the cloud itself. This electric field is not just confined within the cloud, it extends all the way down to the ground, forming a connection. The ground beneath the cloud, intrigued by the negative charges in the cloud, starts to gather a positive charge. This creates an additional electric field between the cloud and the ground. These electric fields, both within the cloud and between the cloud and the ground, create a complex network of attraction and repulsion between charges. This network is the foundation of our lightning story. But what happens when these electric fields become too strong? The answer lies in a phenomenon known as dielectric breakdown. This intriguing process happens when the electric field within a cloud, or between a cloud and the ground, becomes so powerful that the air, which usually acts as an insulator, simply can't hold up any longer. It breaks down, opening the floodgates for an electric current to pass through. But it's not just a random discharge of electricity, it's a carefully choreographed dance of opposing forces. Imagine a step leader, a conductor of sorts, made up of negative charges. It begins its descent from the cloud, moving steadily towards the earth like a conductor leading an orchestra. But it's not a solo performance. From the ground, a positive streamer rises, reaching out towards the descending step leader, like a dancer responding to the conductor's call. The air between them fills with tension, the electric field growing stronger with each passing moment. It's a silent standoff, a battle of wills, until the moment of dielectric breakdown. The air can't resist the electric field any longer, and it gives way. The step leader and positive streamer meet, and in that instant, a powerful electric current, a lightning bolt, is born. The energy released is immense, lighting up the sky and leaving us in awe of this awe-inspiring spectacle. And there you have it, a bolt of lightning, a brilliant display of nature's power. But this fascinating natural phenomenon is not without its dangers. As we delve into the annals of history, we come across instances where lightning has wreaked havoc, leaving behind trails of destruction. Each disaster is a grim reminder of the devastating power that this natural phenomenon holds. Let's go back to 1994 in Dronka, Egypt. A train, bustling with passengers, was struck by a lightning bolt. The result was catastrophic, leading to the tragic loss of 469 lives. It was a disaster that left an indelible mark on the country's history. Moving halfway across the world, we find ourselves in Bangladesh in 1977, an event remembered as the cursed twin cyclones. The cyclones themselves were destructive, but the lightning that accompanied them added to the severity. The death toll from these combined forces of nature reached an astonishing 26,000. Then, there was the soccer match in Corrientes, Argentina in 1991. A seemingly ordinary day turned into a nightmare when a lightning strike caused numerous injuries, turning the field into a scene of chaos and panic. In 2011, a school in Uganda, Africa, became the target of a lightning strike. 18 innocent lives were lost that day, an event that shook the nation and the world. And who can forget the Manchac swamp disaster in the USA in 1915? A lightning-induced fire caused a train bridge to collapse, leading to numerous fatalities. These disasters are a testament to lightning's destructive potential, often occurring as part of larger natural events. Each of them serves as a stark reminder of the broad spectrum of effects that lightning can have. As we delve into the science and history of lightning, we should never forget its power and potential for destruction. These incidents remind us to respect and prepare for the unpredictable forces of nature that surround us. Lightning, a beautiful yet destructive force of nature, reminds us of the awe-inspiring power and unpredictability of our planet.